Solve one problem on heat conduction through extended surfaces with condition fin with insulated end. We will read the given question. Both ends of 6 mm diameter copper rod U-shaped having K is equal to 330 Watt per meter Kelvin are rigidly connected to a vertical wall as shown in diagram. The temperature of rod base is maintained at 100 degrees Celsius. The developed length of rod is 50 cm and is exposed to air at 30 degrees Celsius. The combined convective and radiative unit thermal resistance of rod is 30 Watt per meter square Kelvin. Calculate first the temperature at the center of rod. Second, heat transferred by the rod.
Let us understand the given data with the help of diagram. It is given that the U-shaped copper rod is connected to rigid wall whose temperature is 100 degrees Celsius. So we will draw here U-shaped copper rod and here the wall temperature is 100 degrees Celsius. Now we will plot the given data. Conductivity of this U-shaped rod of this material is given, that is K is equal to 330 Watt per meter Kelvin. Then the conduction and convective heat transfer coefficient H is equal to 30 Watt per meter square Kelvin. Surrounding temperature is also given 30 degrees Celsius. Then the diameter of this rod is 6 mm. And what is the total length of rod? So if we observe here, this total length of rod is 50 cm. That is also given in the question. Now we have to find out what is the temperature at the center of rod. So if we observe here, I will draw the section X at the center of rod and we have to find out temperature Tx at this point. Now how to solve this question? So if we observe the heat transfer through the conduction as well as convection process taking place along the rod, then as the distance from this base is getting increased, then the heat transfer, that is getting decreased. So at the center of this rod we can say that the temperature gradient, that is d theta by dx, will become 0. So it is so much minimum, that is the temperature gradient. So we will consider here d theta by dx is equal to 0 and we will consider this question for the fin with insulated end. Now we will consider here the two fins instead of this U-shaped rod. We will consider here are two fins, that is here is the first fin, each of 25 cm length, that is 25 plus 25 will become 50. Now at the base here is 100 degrees Celsius temperature. Now how the heat transfer process is taking place? So here the heat is getting transferred from this base towards the end from the conduction process through this material, as well as heat is transferred to the surrounding by convection process. So when this conduction and convection heat transfer is taking place, then at this end, that is along this length, at the end of length, here temperature gradient will become 0 and we will consider this question for the fin with insulated end. Now to calculate the temperature at the center, we will consider only one fin, which is having length 25 cm, because if we calculate the temperature Tx at this point or at this point, then these two temperatures will be same, because here length is same and at the base temperature is also same. Now how to calculate the temperature Tx? So for that we will apply the formula for the temperature distribution equation. And now what is the first step? We will calculate the value of m. So value of m is equal to under root of Hp by Ka. So HP perimeter, so this rod is circular because 6 mm diameter is given. So perimeter P is pi into D, and K, that is conductivity, and area pi by 4 D square. So we will put the value. So D is given in millimeter, we have to convert it into meter. And when we put the value, then answer is 7.78. Now what is the temperature distribution equation? So here theta by theta O is equal to cos h m L minus x divided by cos h m L. Now I will mention here. So this is the hyperbolic function of cos, and that is available in the calculator also. So if we press here hype and cos, then we will get here the cos h. Now in the bracket we have to put the value. Now what is our question? We have to find out the temperature Tx. That is, if we observe at this point Tx, x is equal to L, because L is equal to 25 centimeter. So here we have to put the value, that is cos h m and L minus x. So x is nothing but L, that is L minus L 0, and cos h 0, that is 1. So here this numerator will become 1. Now what is this theta? So theta, that is the temperature difference in between this Tx and surrounding temperature, that is Tf. So Tx minus Tf we have to write. And what is theta O? That is the temperature difference at this base, that is To minus Tf. So we will consider here this temperature will be To and this temperature will be Tf. So To minus Tf, which is equal to 1 divided by cos h m, m that is 7.78 into L, L that is 0.25 meter. Then Tx minus 30 divided by 100 minus 30, which is equal to 1 divided by 3.57, which is therefore Tx is equal to 49.6 degree Celsius. So this is the answer of first question. Now we will move to the next question. Total heat transfer from this copper rod, that we have to find out. So we will first find out what is the heat transfer from this one fin, which is having length 25 centimeter. So how to calculate the heat transfer when the fin is at insulated end? So we have formula Q is equal to under root of HPKA theta O tan H in bracket ML. So we will put the value. So H value is there, P that is pi into D. So D is 0.006 meter. K value is given. Then area pi by 4 D square. Now outside this under root we have this term, that is theta O. So what is theta O? That is To minus Tf, that is 100 minus 30 into tan H, that is the hyperbolic function of tan, and here m into L, that is 7.78 into 0.25. So here this answer will be for only one fin, which is having 25 centimeter length. So answer is 4.88 watt. But we have to find out what is the total heat transfer from this copper rod. So this Q multiplied by 2, then it will give us the total heat transfer from this rod, that is 9.76 watt.